Hello again, everyone. We do have another interesting test here, which is a kind of simulation and modeling of a three-story building. So here, as you can see here, we have a structure. We have actually three masses, one, two, three masses sitting on top of each other using these springs. And so we are going to see how the system responds to base excitation, which is a kind of simulation of earthquake. So interesting demonstration. I'll just pass it to my esteemed colleague, Stefano.
Hello everyone. So as Hamed introduced the system, here we have three masses. They are connected through metallic beams, and this beam they have a given stiffness. So you can imagine those as springs. And we have a moving base here. So this is basically a model of a building, a three-story building, being excited by an earthquake. So we have three masses, which means the system has 3 degrees of freedom. That translates into 3 natural frequencies and 3 modes of vibration. Let's look for those 3 natural frequencies and let's see what the mode of vibrations look like. I'm going up right now with the frequencies. So the first one should be at around 1 Hertz. So as you can see, the 3 masses, they're all in phase. We're going to come back to this mode of vibration in a bit, but you can already see that the displacement at the top floor is really high. Can you imagine like having a building vibrating in this way? That's probably not really pleasant for the people being on the last floor. Let's go up. Yeah, this is the second mode of vibration, is at 3 Hertz. As you can see, the mass number 2 is pretty still in the middle, while 1 and 3, they are out of phase. They are counteracting each other. Let's go back up. Last one is at 4.7, 1 and 3 are pretty still, and number 2 is vibrating horizontally. Here probably you can see it even. So the other 2 modes of vibration, the displacement is not as high as the first one. So we said like there are few, let's go back to that one, which was at 1 Hertz, where all the 3 masses are vibrating in phase. Yeah, here we are. Let's go back here. So we said like there are several ways of reducing those vibrations. One is to add another degree of freedom, but we are dealing with buildings here, which means usually there are not only 3 floors. Can you, like a building of, for example, like 7 floors has already 7 different natural frequencies. So probably it's not the best way of doing it. What about adding damping? Damping could be great, but a very smart way of adding damping in those, especially in very tall buildings, is actually to adding liquid on the top floor. Liquid has a viscosity. The liquid, while moving around in a tank, is gonna use the inertia to dissipate energy through the viscosity. Each liquid has a specific viscosity though. So if we add some liquid on the top, for example like this, we can probably already reduce a bit the vibration. But as you can see, the liquid inside doesn't really have much space to shuffle around. So the reduction in the vibration, in the amplitude of vibration is not that high. What if we have something like this, this is probably already better because the liquid has more space to shuffle around and to absorb the vibrations. Different liquids act in a different way because of the viscosity. So in this other bottle, I have oil, which is more viscous. And again, probably this way it's already going to be good, but not as good as if we put the bottle horizontally here. Yep. So as you can see, the system is vibrating much less here. Obviously, in buildings, for example, in the Eureka Tower in Melbourne, at the last floor there is a pool, and that's one of the reasons why it's there. Obviously, yeah, it's also going to add value to the property. A pool, it's nice to swim in. And that's why they usually have pool and not tanks of oil. Oil is great, it's more viscous, so it absorbs more, but water is more easily available, and you can swim in water, not in oil. Also, what happens if we put that tank of liquid at a lower floor? Yeah, it's probably going to help absorb the vibrations, but because we have the highest displacement on the last floor, it's not going to be as effective. Yeah, from this rig we learned that if we are trying to design a building and we want to reduce the vibrations of the building, if we put a pool on the bottom level, it's not going to be as effective. If we put it on the top level, it's actually going to help us a lot. Obviously, we have still to take into account the mass that we're adding on the building, because that's going to change eventually the natural frequency. It's going to shift it on the right or on the left. That's why we have civil engineers. It's important to design properly our buildings and to stand also earthquakes and wind.
Yes. May I add something? Yeah. Basically, we can also generate electricity using the vibrating liquid at top floor. Right?
Oh,
because,
true.
yes, so assume that it's vibrating due to wind, or it's vibrating because of earthquake or whatever. So we've got motion of the liquid, and then we can just generate electricity, and then the power of that tower or just of that building is going to be provided by itself.
Yeah.
So that's fantastic.
Yeah.
So we have swimming pool, we have power generation, and we have vibration absorber.
Yes. We do have everything here now.
Thank you.